efficiency is nothing but the multiplication of water application efficiency and the water conveyance efficiency in percentage. Okay. This means this is nothing but the water application efficiency divided by 100 into water conveyance efficiency divided by 100 whole into 100. So, this is the basic thing you have to remember. Okay. So, I think you have already understood what I want to say. So, the next thing. So, here I will calculate, here let us go for the reservoir storage efficiency. This is very simple, reservoir storage efficiency. So, I want to calculate the reservoir storage. That means, here we can say easily, we can say the water diverted from the reservoir divided by water delivered to the reservoir. Yes or no? Here is water diverted from the reservoir into 100. When is what is the input and what will be the output? This is water delivered to the reservoir. This is water diverted from the reservoir. Okay, so into 100. This is known as the reservoir storage efficiency. So, next one is water storage efficiency. This is most important. You just remember. What do you mean by water storage efficiency? Here you can write water storage efficiency. The water storage efficiency means, you just remember, water stored in the root zone. What I am writing? Water stored in the root zone divided by water needed to complete the depleted amount of water into 100 into 100. So, here you can see, let us I am writing, this is a crop, let us this is a field, now this is a crop is there, this is soil, now this is the root will be there, now this will be the effective root zone, let us this is the effective root zone. Yes or no? So, during after irrigation what happens? After irrigation the water will be lost away from the effective root zone. Yes or no? After irrigation water will be lost away from the effective root zone. Water will be lost away. So, now water, so if I am irrigation, if I am applying the water in terms of irrigation, you think now after irrigation, you think now the whatever the water which is present in the effective root zone, they are lost away, and now I am supplying the water to fulfill that depleted amount of water. Yes or no? Whatever the water I am applying, whatever the water from the irrigation, it should be equal to the depleted amount of water from effective root zone, Yes or no? That means, if 5 liter of water is depleted from the root zone, then I will irrigate 5 liter in order to compensate this loss. Yes or no? But what happened? So, I can say if in normal sense I can say actually the net irrigation requirement should be the amount of water which is depleted. Yes or no? But in a practical sense, yes, there are different losses are there. So, always what happens, whatever the water stored in the root zone is less than water needed in the root zone, because let us you think I need 10 liter of water. I need 10 liter of water. I need 10 liter water. which is depleted from the root zone. So whatever the water I am supplying, the net irrigation requirement should be 10 liter. That means the loss of the water should be equal to the gain of the water. The gain means the irrigation water, the amount of irrigation water. So, but what happens now, as I am applying the 10 liter of water, but there are different losses are there during the period of the irrigation. So hence the water stored is less than that of the water needed. This is water stored, and this we can say water we actually need to fulfill the depleted amount of water from the effective root zone. Okay. So how much of water I need and how much water I get, this is known as the water storage efficiency. So this, now you just remember. Now why I will calculate water storage efficiency? Why? Because in which condition the water storage efficiency is more important? In which condition? The water storage efficiency is more important if I have scarcity amount of water, or deficiency. If water deficiency is there, then I will go for the water storage efficiency. Or we can say, if the price of water is high, if the price of water is high, then we will see the importance of the water storage efficiency. Okay. So the next thing is that water distribution efficiency. Water, this is the also important characteristics. Water distribution. So now here we can see water. So here we can say water distribution efficiency. Distribution means how uniformly we are supplying the water. That means now from the field, now I am supplying the water. Here I am supplying the water to the field, yes or no? Here I am supplying the water into the field, yes or no? So now I will see how uniformly the water is delivered to the field. I will see here how uniformly. If the water concentration is more in the channel head, or this is the in this area which is close to the head, and if the water content is very less in this area which is far away from the head, that means the water distribution efficiency is very less. And if the amount of water is present here is almost equal to the water present here and here and here, that means now the water distribution is more uniform, yes or no? So if you want to distribute this water more uniformly, then we have to decide the method of irrigation. Generally we know, let us this is the irrigation channel. This is the irrigation channel in the field itself. Then what will happen? As it is close to the field head, hence the water will take more time. Water will get more time to penetrate the soil. So there might be a chance that whatever the crops are there, these crops will get more water as compared to these crops. So we have to adopt the method of irrigation so that each crop will get equal water amount. Yes or no? This is known as the water distribution efficiency. So if I will say water distribution efficiency, it is nothing but the 1 minus y average divided d average into 100. Okay, yes or no? So here we can say that if y average means So here I can write y average. Y average, it is nothing but the average numerical deviation of the depth of water stored in the root zone from the average depth of water along the irrigation run. So it is nothing but the average numerical deviation of the depth of water stored in the root zone, or we can say average depth of the, it is nothing but the deviation. You just remember, it is nothing but the deviation, which is deviation of the water stored from the average depth of water along the run. So this is the most important characteristics you have to find out. So if I will see the average depth means, so here this is nothing but the average depth. This is nothing but the average depth of water during irrigation. This is nothing but the average depth of the water during irrigation along the water run. Okay. So water distribution efficiency will be decided by the method of irrigation. So I can say this y bar is nothing but the deviation between, we can say, the depth of water along irrigation minus depth of water during irrigation. So now I will take the average value. So in each point, from this will be the y. So let us, I am taking the 10 points. Let us, I am taking 10 points here, here. These are the points are there. So I will take what is the water depth along the run. I will take the what is the water depth along the run, and what is the water depth during the irrigation process. So now I will take the average value so that I can calculate the water distribution efficiency. This water distribution efficiency is more important in case of which will decide the length of irrigation channel. So now you just remember here. So this water distribution efficiency will decide, this will decide the length of irrigation run. Because if the length of the irrigation run will be high, then the upper part will get or the part which is nearer to the field head, it will get more water, and the part which will present far away from the head, it will get less water. Okay, it will get more water, it will get less water. So the water distribution efficiency which will decide the length of irrigation run in the field. Okay. So now the next thing is that. So the next thing we will here find the operational efficiency. This is very easy. Operational efficiency means what is the project efficiency. Operational efficiency means what is the actual project efficiency. What is the actual project efficiency, and what is the operational efficiency of an ideal project. So I am comparing my efficiency. So there is two project, one is ideal project, and from this ideal project I will compare the whatever the my project efficiency is there. So what is the actual project efficiency divided by what is the efficiency of the ideal project. If I am taking the ideal project, then what will be the efficiency? The ideal project. Again this will be the economic irrigation efficiency. This is very easy. We can write the economic irrigation efficiency means it is nothing but the economic irrigation efficiency means the total economic production from actual project divided by total economic production from ideal project into 100. So this is the things. Economics means total production. We can say the total return from the project by the total return from the ideal project into 100. So this is known as the economic irrigation efficiency. So I hope you have already understood what is the 8 types of efficiency are there for calculation of the irrigation efficiency, and you also know that what should be the importance of the irrigation efficiencies. Okay, as I have already told. So go through the chapter. So thank you. So if you are liking this channel, so please like it and share it, as it is very important chapter, and subscribe my channel so that it will motivate me. So thank you.